Good evening. We're going to pick up and continue our graphing of inequalities this evening. However, we're going to do it as a system of inequalities. And just as a system of equations was two equations written together and solved simultaneously, we do the same thing with a system of linear inequalities. However, there's only one method, and that is graphing. So we'll have to graph all of these. We'll start with two that are already in slope-intercept form for us. As we know, when we go to graph any of these inequalities or equations, we want them all to be in slope-intercept form, which these are. So we'll go ahead and pick up here with this first one. I'm going to do it in blue. Y is greater than x minus 2. Now we graph this the same as we would anything that we did in Class A is a single inequality. We plot the y-intercept, which is negative 2. From that point, we rise 1 and run 1. Rise 1, run 1. Okay? That's going to go all the way to there. And then if we bring it back this way, this should be able to allow us to draw a pretty good line. Now remember, that is a dotted line because of our inequality symbol. Okay, our M is 1, our B is negative 2. We already took care of that stuff, and we have a dotted line because of that symbol right there. Now, the next thing we have to worry about is where do we shade that on that line. We have Y is greater than, so we would shade above the line. So that's going to be this direction. Okay, we're going to shade up. We're done with that one for now. This next one, y is less than or equal to negative 2x plus 4. My y-intercept, my b is 4, my slope is negative 2. So we plot that information. 1, 2, 3, 4, down 2, right 1, down 2, right 1. This one's a solid line because of our inequality symbol right there. It's a solid line. We have y is less than or equal to, so we're actually going to shade down. And now we look for the section that has arrows from both lines in them as our shaded area, and that is this area here. So if we were asked to state a solution to this system, we could pick any ordered pair in that shaded area. Negative 3, comma 2, for example. 1, 2, 3, 1, 2. That shaded area represents all ordered pairs that satisfy both inequalities. So I could pick any ordered pair in that area, and it would work for this particular system. It's the common shaded area. Common shaded area. Let's try another example here of a couple that are not yet in standard form. So we'll take x minus 3y greater than or equal to 12. Subtract x from both sides. Negative 3y greater than or equal to negative x plus 12. Then divide everything by negative 3. Since I divided by a negative, I have to switch my inequality symbol. Y is less than or equal to 1/3 x minus 4. So we'll go ahead and graph that. Negative 4 is my y-intercept, and my slope is 1/3. So I go up 1 and to the right 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. And these will both end up being solid lines. I'll show you another method here that would work as well. If we take a look, this is y is less than or equal to, so that would mean we would shade below the line. So we would go and shade that, and make sure you do that lightly. Lightly, that highlighter is supposed to be light for us right now. And we're going to go ahead. We're done with that first one. We have to go ahead with the second one now. X minus 6y less than or equal to 12. We subtract x from both sides first. We get negative 6y less than or equal to negative x plus 12. Divide both sides by negative 6. Y is greater than or equal to 1/6x minus 2. Okay, so again, we go ahead and plot this. My y-intercept is negative 2. We go up 1 and to the right 6. 1, 2, 3, 4, 5, 6. Up 1 and to the right 1, 2, 3, 4, 5, 6. Again, it's going to be a solid line. Pretty close there. Whew, this is a tough one to graph on here because actually our common shaded area is going to end up being over in there because we have to be greater than or equal above the red but below the blue. So it's going to be this blue line extends out. Our shaded area here is this common area right out here. Wouldn't have even been able to use the other highlighter there. So that was a little bit tough. That one's way off the graph. It's a small area. The last one was big. It could be a small area bounded by the curves here as well. Let's take a look at these last couple of examples. I think this is it. Yep. So let's take a look at these two real quick, and we'll go from there. I'll show you that shaded area trick right now. Remember, this is the line y equals 2. So that's horizontal line that goes through y equals 2. It's a dotted line because of our symbol there. And we're less than that, so we'll shade below. So that's our shaded area there for y is less than 2. Now we have x is greater than or equal to negative 1. That's a solid line right there. Now x is greater than or equal to that. That means we shade to the right because the x values get greater to the right. So we would shade this area here. Now the solution area is the area that is shaded by both colors. So that would be bounded by this right here. Okay, so our solution is again this lime green color. It's the area that overlaps that has the blue and the red. The blue and the red. Let's come over here to y is greater than or equal to 0. That is actually the x-axis. We'll come back to just showing the arrows. Greater than or equal to means we're going to shade up, just like that. And now we're going to have x is less than 6. So we go out to x equals 6. 1, 2, 3, 4, 5, 6. And we have a vertical line there. X is less than that. Means we shade towards the left. So our common shaded area, again, we'll do it in lime green, is this right here. So a couple things that we've seen about systems of inequalities is that you graph the inequalities just the same as we did in class. The solution area is the area that is commonly shaded. So if we look at these two examples, any point like that right there, that looks to be 3, negative 2 would be a solution. Or 1, 4 over here would be a solution because they're in the shaded area that is common to both inequalities. And that's how we graph systems. We'll continue to practice those in class tomorrow. Have a great night.